Recon InfoSec. In this video, what we're going to be doing is breaking down one of the oldest, longest running scenarios in OpenSOC.io. The name of this scenario was Urgent IT Update. And essentially, in Urgent IT Update, we're following a fictitious threat actor that leverages some of the most common tactics that you see in the real world, specifically around social engineering and spear phishing campaigns that are trying to urge an employee to take an urgent action. So usually there's some terminology being used, to try to drum up a sense of urgency in the victim. In this particular campaign, what we're observing is an actor that is intentionally trying to gain an access or a foothold into the environment to enumerate the network looking for database servers. Once they find the database server, the plan is to brute force their way into the server and steal the contents, hoping to get some sort of sensitive payload. So let's take a look at this scenario, walk through and debrief all the different things that can be found here as we move forward with decommissioning it. Okay, so now I am taking a look at the DFIR systems that we have available to us inside Network Defense Range OpenSOC.io. So as most participants would be familiar with, Graylog is my central log aggregation point, bringing in data from all the endpoints inside the environment, servers, workstations, firewalls, you name it. So in this particular scenario, the very first opening sort of prompt to our participants was that threat intel came in saying that there was some sort of spearfish campaign drumming up a sense of urgency from the user to do something specific. And I think there were some keywords provided to the user, something particular around the email subject having the word urgent contained within. So there's a few different ways that a participant might have worked through looking for that initial vector to see, was our organization affected by this campaign? So because Exchange is shipping data to Graylog, we actually have the Exchange message tracking logs. So it's a limited view into the email traffic, but it can still give me some of the important metadata bits like message subject. So for instance, if I were to start crafting a query here, message underscore, you notice it's auto-populating a few possibilities here. Subject is the one that I want to go for. So what I would probably first bring to this query is a list of keywords maybe of interest, things that Intel says to be on the lookout for in those message subjects. So for instance, in this particular campaign, I know that the attacker was using some form of the word urgent inside the message subject. So one way I might go about this is with a regular expression query, searching for all message subjects to contain the word urgent. But the thing about regular expression is I'm going to have to be very specific about case sensitivity here because of how regex is implemented here in Graylog. So an easy way to say account for the word urgent with both an uppercase or a lowercase u is just simply to provide an or condition there for an upper or lowercase u followed by urgent. Now you notice I'm surrounding that query with forward slashes as well as .* to indicate any character before or after the word urgent here. And you notice I'm also searching across the last 8 hours, which was expected to be when this impact would have been realized. So let's run that query and see what we get. One message. So taking a look at the one message that we get back, it becomes apparent very quickly that we may have been impacted by this campaign. So let's take a look at what we get back here. Okay. So just as I feared, we did receive an email titled Urgent IT Update, and it was sent to julia.jones@corp.net. The other interesting thing to parse out of this is both the sender address and the return path. Okay, now at first glance, it might not be obvious what's wrong with this email address. But if you were to say, look at this with maybe a better font than the one that's being used here, you'd realize that corp is actually spelled here with a 0 instead of an O. So we've got that sort of that typo, in the email address here that might not catch your eye immediately, and that's kind of what our attacker's banking on here. That they're going to be able to kind of hide in plain sight with a spoofed email address to make this look like it came from the help desk. Now, this is helpful in at least answering the question, were we impacted by the campaign? But this doesn't exactly tell me any other details around the message. I don't know what the contents of the message were. I don't know if it had an attachment connected to it. So I might need to switch gears and check out another system that might be able to answer some of those other questions. But taking note of that message subject would be useful here to carry forward into that other system. So the other system that I would then take a look at is Moloch. Now, because Moloch is essentially performing full packet capture of the entire environment, we're capturing that SMTP traffic coming into the environment, hitting the Exchange server. And since that's clear text, we're going to be able to do a deep dive into that traffic. So one approach that I would take here in Moloch is to simply start typing a field name that I might be looking for. Even if I don't know what the exact field name is, Moloch will do some autocomplete and suggestions to let me know. So for instance, here we are looking at the email.subject field. That's the one I want. And notice the syntax is a little bit different here in Moloch, but ultimately writing a query is writing a query, right? So I've got my email subject here, the one that I learned about from Graylog. I'll just want to make sure that my search period here is adequate to cover the time frame. And then let's see what we get. All right, so running that query in Moloch over the last 6 hours brings back 2 sessions that matched my, my query. And you can see right here from the metadata being parsed out, it's definitely an exact match on what I was hoping to find. So taking a look at either of these 2 sessions, and I want to call out the reason why there are 2 sessions here. So if you'll notice, the source IP and the dest IP for each of these sessions is slightly different, and I'll explain why. So in both situations, the source IP here is the 57.1 address. The 57.1 IP is actually our internet service provider's upstream gateway. So all mail in this environment comes from that IP address. So that makes sense. But you notice the dest IPs are a little bit different here. So let's look at the bottom one first. The dest IP is going for 57.97. So that's actually the WAN IP address of the corp network. So what I'm seeing here is I'm seeing the pre-NAT and then the post-NAT traffic, because Moloch is capturing at 2 different network segments. So it's essentially seeing the same traffic twice, which is a better problem than not having the traffic at all. So either one of these sessions will probably have what I'm looking for. And you can tell by the size of the sessions that they're, fundamentally about the same. So let's just take a look at, say, this bottom one here. All right, so expanding that session, I can now do a deeper dive on the metadata that was carved out by Moloch. So zeroing in around the email-specific metadata, of course, it's parsing out all of the different headers, the familiar subject that we're now acquainted with, the sender, right? Now, remember, when we saw the sender in Graylog, it wasn't quite as obvious about the 0 contained here in the email address. It's a little more obvious here in Moloch because it's lowercasing these parsed fields. So that's kind of helpful just to kind of assist an analyst that's looking at this. So the really cool thing, though, that Moloch's going to bring to the picture here is the entire packet capture of this session to include the contents of this email. So I can see those raw headers, but more importantly, I can see the contents of the email here. So now I can learn that, not only did this email contain a hyperlink here with a potential malicious executable, but I can also kind of observe some of the behavioral characteristics of this campaign, right? The fact that they address the victim as user, right? Which we all know is one of those typical signs when it's a depersonalized email that it's something that's kind of mass produced. And then of course that call to action. This is an urgent message from IT. You might want to do something about this. There's a critical vulnerability and you need to apply this patch to your computer. Now, looking at this URL, again, we're sort of playing off that hiding in plain sight tactic, right? At first glance, one might think that there's nothing unusual about this URL, but on closer examination, you'd see that we're not looking at a W here. We're actually looking at 2 V's side by side. So windowsupdate.com/update.exe, definitely not a good thing to see inside of a message like this. So now that we've essentially confirmed from 2 different systems that, yes, the organization has been impacted by this campaign, the next important question to chase down is, okay, what system could update.exe possibly now be exposed to. So there's a couple different pivot points that we could use here. Knowing, first of all, that Julia Jones was the only recipient of this email is helpful, because I could just simply find out what system does Julia Jones use. But of course, if I'm assuming that update.exe has already been downloaded and possibly executed, that's another possible pivot point. But I'm going to use first the Julia Jones pivot, and we'll see, first of all, what system does Julia Jones use in this environment. So one of the cool things about Graylog is I can sometimes just throw something as simple as julia.jones into my query and just see what comes back. Got quite a few events, but that's okay, because all I'm really trying to do here is find out what is the highest prevalent source of events for Julia Jones. So right off the bat, I see that ITO3 is the most prevalent system shipping events that have the word julia.jones in it. So it's a decent assumption to make that ITO3 is probably Julia's workstation. So then what I might do is add ITO3 to my query. So now I'm only going to examine events that are occurring on ITO3. So the next likely pivot point is looking for any sort of process creation events that might be connected to our known malicious email attachment. So again, going back to the body of the email, we saw that we have an executable here called update.exe. So I might be interested in whether or not update.exe occurs anywhere in the events on ITO3. So we'll go ahead and run that query. Okay, so right off the bat, I've got 31 hits. So I'm a little concerned at this point, right? Because yes, we know that Julia Jones received the email, but it wasn't until now that we knew for sure that there's likely some impact on the workstation of potential malicious executable. All right, so now that we've filtered down for all events occurring on ITO3 that match a term that we already know to be connected to our campaign, update.exe, we can very quickly start to get an understanding of what all is taking place on this system that might be connected to this incident. So scrolling down to the very, very first hits that I get on update.exe, I start to see exactly the thing that I feared the most, and it's that we have Internet Explorer launching with an argument of the malicious URL contained inside of our email. So that's usually a surefire sign that, yes, a link has been clicked, right? We can see that that's attributed to julia.jones, who we already know to be the recipient of our malicious email campaign. Now, this sysmon event that essentially tells me the same thing gives it to me a little bit more of a process hierarchy kind of way. So I can see a little bit more around process parent and child as well. So I can see that it was Outlook.exe that actually launched iExplorer.exe. And so that's going to help corroborate the story that she visited the link, but she visited the link as a result of clicking on it inside of Outlook. So we see Outlook launching Internet Explorer with the command line argument of the windowsupdate.com/update.exe. So, all right, at this point, we know for sure link's been clicked. So let's keep going and see what else happens here. So the next few events that we see here are created by sysmon, but we're seeing a file creation events. All right, now this is again a sysmon only type event, but can be incredibly valuable in understanding events that are unfolding on an endpoint from the moment of compromise. So here what we're seeing is a file creation for update.exe sitting in Julia Jones's download directory. And we can even see the process that was attributed to the creation of that file, iExplorer.exe. So this makes perfect sense if you would expect, how a browser downloads a file. Well, the browser is the process that's responsible for creating the file. And that's exactly what we're seeing is the creation of update.exe. So at least now we know for sure the full path to update.exe at this point. Yes, it has been downloaded. All right, so we've got a few additional artifacts. Some of these are going to be a bit redundant, so I'll continue going through here looking for the key executions. All right, so now what we see is we see the actual execution of update.exe. So we've seen the link clicked and browsed to. We saw the creation of update.exe, but now sysmon is reporting that update.exe was actually launched. And we see that the parent process for update.exe was Internet Explorer, which is usually indicative of when you go to download a file in IE or any other browser for that matter, when the download's finished and it prompts you, what would you like to do next? You can simply run it right there from the browser dialog, which would make the browser the actual parent process for that execution. So that's likely what took place here. So we now know that yes, we do have execution of update.exe. Now, I want to spend a minute to highlight some of the really valuable things that we get in these sysmon event logs. So sysmon is doing some really helpful things like hashing of these executables. So now I know right off the bat the MD5 and the mhash, and if I had the SHA-256 option enabled in my sysmon config, I'd have that here as well. But either of these would be a really quick thing to throw into an open source intel to find out what's going on here. Continuing on, let's see what else we've got unfolding here. So we've got an image loaded followed by several network detections, event ID 3s from sysmon showing that update.exe is making connections to network locations. So let's take a quick glance at that. Taking apart this network connection, there's some very interesting things that we can parse out of this. So for one, the dest host name. So this was the host name that was first referenced by the executable as it was reaching out. But at this time, the host name resolves to this dest IP. Both of those are important things, okay? Because from an observable standpoint or an indicator of compromise, I know that this domain here is tied to this IP address here. I'm going to collect both of those and log those as observables. But a few other things that I can take note of, for instance, geolocation, Istanbul. So we're seeing a Turkey-based IP address here. And then continuing on, a couple of other things that should pop out, like destination port. Again, for the red teamers out there, you're probably very familiar with the quad 4 here. That's our default Meterpreter reverse shell port. So again, indicative of a very lazy attacker that didn't even bother to change the port number for his reverse shell, and we're seeing the very predictable 4444. So again, just kind of wrapping up this network connection, this is a pretty important moment here because not only did we have execution of update.exe, but now we're seeing an outbound network connection to a foreign IP address over a known shady destination port. These are all things that we're going to take note of as the moment that an actor might have gained a foothold inside this environment. Another thing that I actually like to show you is the usage of OS query to enrich something that we currently know about. So for instance, we know about this executable being run on Julia Jones's workstation, and sysmon was able to tell us a little bit about it. For instance, the MD5, the mhash, but let's say for one reason or another, I need the SHA-256, and sysmon just hasn't provided that to me. There's another way that we can get additional information about this executable because of the fact that we have OS query deployed in this environment. So taking note of the path of this executable and the system that it's located on, I'll come over here to OS query and I'll start to fill out a query here in our builder. So Windows is the operating system that I'm interrogating. IT03 is the system. Now the table that I'll use here is one called hash, which essentially allows me to gather hashes of any executable or file on the file system. Now here I'll just say return all columns. Now this is where I need to put my criteria for the file or files that I want hashed. So I'll say based on the path being like C users Julia Jones downloads update.exe run query. So you notice while this query runs, it's showing me here what the raw SQL version of that query would look like. But essentially that's being done on the back end by our query builder here. Okay, great. So we've got a result from IT03 for this directory, this path. I've got SHA-1, SHA-256, as well as MD5 here. So again, I can just simply plug that in to say virus total, see what virus total has to say about this as a very quick way to enrich something that I found in the environment. Another really cool thing that I can do with OS query that goes above and beyond what even sysmon is able to tell me is this process still running on that system? Because OS query is performing a real-time interrogation of the system, I can get point-in-time answers to questions like that. So one of the tables that would be most interesting here would be the processes table. So I can click on processes, and I've got IT03 here selected. I can say select all columns from processes, and I can simply say where, let's say name is like, we'll just simply say update. So again, reminding you that the percent signs is our wildcard in SQL. So let's go ahead and run that query and see if we have any processes running where the name basically contains the word update. And it looks like we do. So we have a process here running. The working directory is this location here. And just noticing that our path, our command line arguments, all kinds of good things here available to us. And one really cool thing that OS Query will tell me is whether or not that process is on disk or not. Now, in this case, it is, and of course we know that because we saw that file being created on the disk. But this is one of those really cool features of OS Query for looking for the infamous fileless malware, right? If there's a process running on the endpoint that doesn't have a corresponding binary on the disk, that on disk flag would likely be set to 0, which is a really cool hunt for looking for that type of activity. But in this case, the main question that I'm answering at this point is the update.exe executable is still actively running on Julia Jones's workstation. So from an IR perspective, that could be an important detail. All right, so taking a closer look at the network connections that we observe that are connected to the update.exe process, there's some other really important things that we might learn about the activity that the attacker carried out on this system. So I'll go ahead and reduce my results down to only the network traffic by specifying event ID 3 here. I've got 19 results in the last 8 hours. So one of the first things that I might do is take a look at the quick values on destination IPs to know what IP addresses did this process communicate with. So I've got a hit here on obviously our attacker IP address. We've connected that one to Turkey. But then I've also got an IP address here of a local system, and I've got 18 counts of that. So that's definitely something that I want to take note of, because that might have increased the scope of my intrusion here. So knowing that I'm already aware of this activity here, I'm curious to learn more about this 42.33 activity. So one thing that I might do is customize this graph here to add the dest port field to this graph, so I know exactly what ports were being communicated to on these different systems. This makes things a little more obvious about what might be taking place here. So we know that our attacker is using the predictable 4444 for the Meterpreter outbound connection, but when the connection was made to 42.33, it was using port 3306, which is of course MySQL. And so if we go and take a look at our range diagram for the 42.33 IP address, we can see here it is, it's our prod SQL 001 server. So it is in fact a MySQL server. So now it's important for us to know that a system down here in the IT subnet is reaching over to the MySQL server, which could typically be a normal activity, but with the connection to the update.exe process, that's our indicator that it's likely not something that should be happening here. So we'd want to definitely dig a little bit further and understand what was taking place here against this SQL server. All right, so while we're talking about the Sysmon network connection events, there's something else that I want to call out. So the fact that we see these network connection events is only usually indicative of successful connections. Sysmon will not necessarily report attempted connections that did not have a successful handshake. So something else that we could do is we could go and query other data sources to find out, did this system attempt to connect to any other systems, and maybe this was just the only one that succeeded. So taking into account the source IP here in this event ID 3, that's the source IP address of IT03. So I might go say check Moloch to see what else did Moloch observe coming from this system. And then knowing that the port that was being used here, 3306, let's at least see if it agrees with what Graylog has to say. So yes, I do see a lot of sessions in here that match exactly what Graylog had to say. I see our known compromised workstation talking to 42.33, which is our SQL server. But are these the only systems that are talking? So let's go over here and look at the connections tab. that's where another story kind of lies waiting to be told. So you can see here, 17.180 is our compromised system. There are a lot of other destinations caught up in this traffic. So if we go back to sessions, it'll make a little bit more sense of what's taking place here. Notice all these 42.33 connections all have some number of packets and a pretty decent size of traffic being exchanged here. But if we keep scrolling, we start to see other destination IPs in this list with very low packet counts and very low byte counts on the source and destination, respectively. So if I just take a look at one of these kind of empty sessions, you can see there's really not much going on here. This is likely an attempted TCP connection to a system that probably wasn't even listening on that port. Therefore, there was no handshake, and therefore there was no substantial traffic. So Sysmon did not report all of these attempted connections. It only reported the one that succeeded. And so it's important for us to sometimes check other data sources to understand what else might have happened here. So typically what this would tell me is that before the attacker just simply found the SQL server, he was scanning for a SQL server on 3306 across this entire subnet. So it makes a little bit more sense now how we might have discovered one. All right, so let's focus a little bit on the time when the attacker is making connections to the SQL server, and let's see what we can learn from that. So looking at these events here, I can see that the attacker starts making contact with the SQL server around 1950 all the way up until 2007. So what I'll do is I'll zero in my time frame on that window of time and see what we can determine on another system that might have information for us. So what I'll do is I'll clear this out and let's go see what our SQL server had to say. I believe prod SQL. All right, so we've got quite a few events being shipped from the SQL server because it is in fact being used by production applications in the environment. So slim chance that I'm just going to stumble upon things of interest here. So what I might need to do is continue to reduce the data down based on the things that I already know. So what I might do is start to assemble a list of keywords based on the things that I'm already aware of. So what I'll do is I'll add some things like, for instance, Julia.Jones, right? As we know, Julia is currently a potentially compromised user, but I also know the source IP address of Julia Jones's workstation, which is this IP address here. So again, I could, use my imagination to come up with any different keywords that might help me find a pivot point in these SQL logs to find out what happened around the time that the attacker pivoted to the system. So we've got 44 messages returned in the last 8 hours. So if I scroll down and kind of work my way up, the activity that was taking place becomes a little more obvious, right? So what we see is we see a series of connections followed by access denied messages, right? And so continuing on, there's a long stream of these highly indicative of potential brute force activity. Now, of course, the only thing that we fear more than brute force is a brute force followed by a successful authentication, right? So scrolling all the way up, just reading these in sort of temporal order, we see a lot of access denied, access denied, access denied. But then here at the end, we see a final connection at 2013 that has no subsequent access denied message, indicating that that might have been a successful authentication. But we might have to pivot in order to understand if that's in fact the case. So let's see what Moloch can tell us, because again, Moloch is capturing traffic between these network segments, and in a lot of cases, SQL is actually a clear text protocol, so we might actually be able to take a peek and see what exactly is going on here on the wire. So this is the same query that I had before, looking for all traffic originating from Julia Jones's workstation ending in 17.180. But I'm filtering specifically for traffic to or from port 3306, right? So filtering out a lot of the additional noise that might be on the wire there. Now, looking specifically at our target system here, 42.33. As a matter of fact, I'll even add that to my query as well, just to eliminate all that other noise down below. So adding that to my query, let's refresh it. Now we only have traffic to and from our known affected systems here. So again, remembering that we had that long stream of failed authentication attempts. And that would kind of line up with the low byte count of these initial connections that we see here, because there was not an established session to then continue carrying out transactions. We see very short and very small sessions here, very low packet counts. But then you notice at 2013-52 UTC, the session ending at 2014, we see a much larger session with far more packets than all of the other sessions. And again, this lines up with that authentication or that connection that we saw in Graylog, where there wasn't a failed authentication connected to it. So let's take a look at this session, because this might be the one that that we're going to be more concerned about. So again, looking at some of the metadata that Moloch is very helpfully carving out for me, I can see some of our layer 2 information, but I can also see some of the application specific data. For instance, the user that was being passed in the transactions, which was Julie Jones. I can even see the header of the version for the MySQL server here, if that's important to me for any particular reason. But then, of course, where things really get interesting is when we can look at the contents of that network traffic right here in clear text. So this is where we can start to understand what was taking place here. So again, I'm not going to go super deep into the weeds on trying to read SQL syntax, but to be honest, we don't have to be SQL database administrators to kind of get an understanding of what's going on here. So I see a few references to things that might be database names, right? It could be a database here called customers. It's enumerating maybe a schema of the different tables in that database. But continuing on, I don't have to go very far to really start to understand what might be contained in this network traffic. So the data on the right-hand side is the traffic coming from the SQL server, right? And we can start to parse out some pretty important things in here. What appears to maybe be email addresses, maybe first last names, addresses, definitely not the stuff we want to see getting dumped out of a database, right? This could be some sort of customer record database. So one of the things that we would typically do with a data dump like this is very quickly get this into something where we can actually parse it and read it and understand what's going on in it. In this particular scenario, one of the questions that we ask the participants is, how many unique records occurred in this data dump? Because of course that translates to how many letters are we sending out to our customers tomorrow to let them know that their data has been compromised. But it's okay, because we're going to buy them 6 months of credit monitoring. So one of the tricks that we have up our sleeve here is the CyberChef integration of Moloch. So right here, I can access CyberChef, and I can take all of those destination packets and take them right into CyberChef, where I can do all sorts of interesting transforms and extractions on that data. So one of the first things that I'll likely want to do is identify something in this dump that's likely going to be contained in each record, right? And again, that's a bit subjective, because there's a few different things that I could pull out of this. Maybe it's the presence of, male, female. If that's going to be contained in every one of these records, then maybe I could latch on to, the word male, which would be a subset of either of those. But actually, one that I would prefer using is, say, the email address, because that's something that I can build a more reliable regular expression signature for. But the beauty of CyberChef is I don't have to build that signature at all. So one of the many recipes available to me in CyberChef is extracting many different things. And one of those things is email addresses. So I'm just going to simply let CyberChef make quick work of that. So right here, CyberChef has extracted a long list of email addresses that could be indicative of every one of the customers affected by this breach. But here I can even have it count that, and I can see that there were 952 total email addresses found in this data dump. So the next really hard part here is trying to prove whether or not the database was actually exfilled from the environment. We did see in Moloch that it was dumped from the SQL database to Julia Jones's workstation, but we may not necessarily have the opportunity to see it going out to the attacker's IP address because the encryption being used by the interpreter payload. So by just simply looking at NetFlow, I've crafted a query here that would give me a little bit more insight. Now, just to show you sort of what's going on in this query, you can see I've got two different groups specified. I've got either the victim workstation or the database server, or the victim workstation and the attacker's C2 IP, so that I can see all of those sessions kind of shown in one view here. This makes it a little bit easier to sort of parse out what's taking place. So where you see on this histogram, where you see this surge, and remember, this is, right around the time we see that successful authentication at 2014 UTC, we see a surge in bytes coming from the destination, which in the case of the first half of the conversation, the destination is the SQL server. So we see a surge in bytes coming from the destination to the victim system, which is Julie Jones's workstation. But shortly after that, we see a surge of bytes coming from the source, which is the victim workstation, to the attacker's IP address. Now, an even easier way to sort of make sense of that NetFlow is to sort all of these sessions based on the data bytes. And what we'll see here is we can see, based on the time frame here of these sessions, we see when the transaction takes place between the victim workstation and the SQL server. And let's just say that's about just under 200,000 data bytes. And then very shortly after that, we see a session ending where the conversation is between the victim workstation and the attacker's C2 IP address for a very close data byte count of 208,000. So again, just sort of, we're taking a guess here that based on, a bump in the wire, that the data might not only have been moved east to west, but then might have also gone from south to north and exfilled out to our Turkish IP address.